too high. Is that in the glare? Is that up in the glare for you guys? You okay? It's good? Okay, well, I'm trying not to work up here because I know there's this blue glare. Let's take a look at this one here and see how you might do this. You know, you have the calculator available to you. Not that you need it, but you're going to put 8 first into G, excuse me, negative 8 first into G, so it's going to be minus 4 times negative 8 squared minus 4 times negative 8 minus 8. And then you're going to come back and put the result of this into F. Okay, so one possibility here, since you have this thing, what does that say right there? Minus 4x squared. In my y equals, if I put minus 4x squared minus 4x plus 8.
Minus 8.
Oh, thank you. Hard to see. That's fine. Okay, if I open, you can see this here. If I use that like this, and hit my zoom 6 button here, I can look at this. I don't really care to look at it. All I want to do is find the value when x equals to negative 8. And not that you couldn't do that by hand or anything, but it's nice that you have this calculator because you can find the value for anything by any value here at negative 8. And minus 232. So when you put negative 8 into G, you get minus 232. So then we're going to finally take F of minus 232. F is what? 5x plus 2? So this will be 5 times minus 232 plus 2. Get minus 1158. Circle the answer. Okay. I could have done all that without the calculator. I just figured since you have it, do the composition. Notice that it says find F F composite G, and it doesn't say for a particular value. So now you don't have an option of doing it for a particular value because you need to find it in the general sense. This is where the notation will help you the most. F composite G of X is the same thing as F of G of X, which means really you're taking G and you're putting it into X. So I would write, G putting into F, sorry. I would write F. F is 3 times X plus 15. That's right here. And what's going to go in for X? 4x minus 1. And this is relatively basic. This is 12x minus 3 plus 15. So 12x minus 12. F composite G with 2 other functions. I'm going to put G into F. Actually, that's kind of good because I have the square term for G. I would much rather do that first than to take this term and put it into G because then I'd have to square a binomial. Not that I can't do that, but in this case, so you actually luck out because this is going to go into here, so you're not ever going to have to square anything. And you can write this probably pretty easy. 6 times x squared minus 3 plus 7. So 6x squared minus 18 plus 7. What is that? 6 squared minus 11. 6x squared. Hopefully it's one of these. That's right. Yeah. Get the calculator out of the way. Positive function f positive g. Remember we do what first here? Well, this one is a rather easy example because when you're talking about the composite functions, you want to look at the domains of each of the individual functions first. And here, the individual functions, do they have any square roots or do they have any division? So these are all real numbers and all real numbers, so the composite will be all real numbers. So you've done that. Now that you know that it's all real numbers, you need to know that all real numbers is represented in interval notation as minus infinity to infinity. So clearly this is the answer. This one is from 0 to infinity. This is from minus, well, it looks like 8. This is actually kind of funny right here if you think about it. I guess what they did is they take both the infinity term and turn them right side. I think that's a funny answer. Maybe that's just me. A lot of things here had to, that's what happened. So 1 over x minus 2, and what are we doing again? The instructions say f composite g? Yeah, see up here, right here, f composite function, f composite g. So let me write that down so we know which order, right? Because this is important. F composite g will have a different domain than g composite f. So now you must know the order. That means we're going to go in here. This is the way it really should be written. You're going to go in here first. So that means the domain of our composite function automatically gets the domain of the g function for free, because since you're doing g first, g is the first number you're going into, so the composite will get the same domain. What is the domain of this function right here? Well, remember, you can't take the square root of a negative number. So if you have a problem with this, start putting numbers in to see which one makes a negative. Okay, how about 10? Does that make a negative number under here? 10 plus 1, 9 plus 1, 8 plus 1. All the way down, 0 plus 1 is good. Minus 1 plus 1 is 0, though. But can you take the square root of 0? Yes. Square root of 0 is 0. Minus 1 is fine. How about minus 2? No, that's too small, right? As a matter of fact, anything less than minus 1 is going to give me a problem. So I want to make sure that x is greater than or equal to minus 1. Because it can be 0. We're not dividing here. We're just taking square roots. Okay, so now, once we come out of this, though, we go into f. We need to know where f's problems are. What is the problem with f?
3.
That's actually a 2, right? But I know you meant that. X cannot equal to 2.
Well, it's all done, it'll be 3, so skip that.
Yep. Okay, so you're looking for the spot where x plus 1 makes a 2 come out. You can square both sides, or you can just see what's going to make a 4 in here. When x equals to 3. Okay, square both sides, you get x plus 1 equals to 4, and then subtract 1, and you get x equals 3. But I think you can see in here 3 plus 1 would be 4. So you better not let a 3 into g, because if you let a 3 into g, a 2 comes out, and this doesn't take 2. So is 3 inside this? It is. Minus 1 and up, 3 is in there. So we need to take 3 out as well. Okay?
How did you get there?
Okay, when you put 3 into g, what is your answer? And what does f not take? So I should never put 3 into g. Okay, so therefore, this is now the domain right here. That step, well, whatever step we're on there, that's the final answer, really, except for the, now you have to change that to integral notation. Okay, so not only do you have to know your domains, you have to know how to write them this way, I guess, and then to turn around and write them in integral notation. What this says is you start at minus 1 and you include it. And you start heading off towards infinity, but all of a sudden you run into the number 3, and you have to kick him out and then head off to infinity. Does that look like any of the answers?
C.
C.